Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be modeling and printing this fidget cone. Now, this is something that has been around for a while. I didn't come up with the idea or the design, but they're actually really easy to model, so I thought we'd walk through the process of modeling them so you can understand the different parameters you need to think about, how you can model it yourself, and variations you might want to make. So the first thing that we're going to do is obviously we're using Fusion today. You could do this in whatever CAD package you want, but we need to start with a cone. I'm going to go ahead and just start a sketch on my front plane and use my line tool, and I'm going to create a vertical line. Now I'm going to hit OK here and escape because I want to turn this line into a center line. Now the reason for using this as a center line is because it'll automatically grab it as an axis of revolution, and it'll automatically convert my dimension values to diameters. So then we're going to use our dimension tool, that's D on the keyboard, and I'm going to make this 50 millimeters tall. There's no need to make it huge. You can make it smaller if you want, but this is a good size, easy to print, it will have enough resolution. Next, I'm going to use my line tool. I'm just going to simply come out here, come down, kind of find the intersection, and then back over. Then again with my dimension tool, if I select this point here first, and then the center, this is going to give me a diameter value. I'm going to have the base be, say, 40 millimeters, and we'll do the same thing at the top. And the top, I'm going to make 10 millimeters. So not a super big cone, but it's big enough for what we need to do. Now you will notice, even though this is a center line, which is a type of construction line, it still gives us this profile. If this was just a traditional construction line, we would not have the profile there. So when I hit Finish Sketch, and I do a revolve, you can see it automatically grabs that center line for us as the axis of revolution based on how it was defined in the sketch, so we can say OK. We are going to need two of these so you can revolve it again. I'm just going to use Control-C and Control-V to copy it, and then I'm going to hide the copy. The next thing that we want to do is we need to define the cutout, the twist that's going to be cut out from this first cone. The way I like to do this is I'm going to start on the bottom and start a new sketch. Then I'm going to project. We don't really need to do this because the profile is automatically there, but I'm going to project that edge and then hide the body. The main reason that I project the edge, and I'll actually go ahead and undo this and just hide the body, even though we have the profile, we don't see the edge very well. So if you want a visual reference, it can be good to project it. Again, P on the keyboard, which is one of the funnier shortcut keys, of course, and let's go ahead and hide that. We'll make this construction. You can do it over here, or you can hit X on the keyboard. And the next thing I'm going to do is create another circle. So C on the keyboard for another circle. This time, this is going to be actually where our cutout goes to. So 30, 35 millimeters, somewhere around there is going to be fine. You want to keep in mind that with the sort of distance between these two, you don't want to make it too thin because then you aren't going to have much material left over. And it's going to start to become a problem with things like the number of traces that you can do when you're 3D printing. So 35 seems to be okay. You can see that we have another line here that's not construction. So I'm going to hold down the left mouse button, select the one that's not construction, and convert it here. This one actually doesn't need to be a regular line as well, so we'll make that construction. The next thing I'm going to do is I'm going to draw a line, a vertical line here. And from that vertical line, I'm going to come out to the right. And then I'm going to draw another line at an angle. We'll explain this in just a second. All of these can be construction. So select them all and hit X. I'm going to go ahead and pull that off to the side. So the first thing that we want to do is add a dimension. So D on the keyboard, we're going to go from here to here. This value needs to be represented by the number of twists or threads that we want to create. So the way that I like to do this is I like to do 360 degrees divided by 2 times the number of twists. So we can put that in brackets if you want, or you can just do it in your head, but 2 times, let's say 5 twists, and close the brackets and hit enter. That's going to give me 36 degrees. Now, if I double click on this and say, well, I decided I wanted to do 6 twists, it's going to change it to 30 degrees. So we're going to go back to 5. In this case, I'm going to just do 5. But the main reason that we need to do that is because the complete center of this is going to have to be cut away. It's going to have to be open. So we're going to have it open based on the number of instances in this pattern. If you want to get fancy and you want to use parameters and drive it with a number of instances so that it can update easily, then go ahead and do that. It's not that hard to change in this case. But now what we want to do is I'm going to start a line. I'm going to have it come up here and be parallel as the default. It can be collinear. It doesn't really matter. And then I'm going to go to an arc. So I'm going to do an arc from here down, make it tangent, and then from here down to make it tangent. The reason I have that line here is because the tangency won't automatically get applied to the arc, but it will if there's a reference line there. So that's why I have that reference line. And then we just need to define some values here. So the way that I'm going to do this is I'm going to give this a radius value. Just looking at it on the screen, it looks to be about 3.5, 3.75. And then this one here, let's go ahead and do, it's 7, but I think that's a little too narrow in the middle because we're going to need the space to put parts together. So let's try 6 and see what that looks like. It's probably going to be okay. We want to make sure that these are tangent, and you can kind of see we can pull these around. And we can define this by the distance here. So I'm going to use, again, D on the keyboard, and I want to drive the distance here. So let's say 5 millimeters. And now we've got half of our profile. We're going to mirror this. So this one, and this one here. If you have trouble selecting, again, just hold down the left mouse button, and then you can select the correct line easily. Then we're going to mirror that about that. And now we've got our profile. So bring our first cone back, create another sketch. This time we're going to just pick a plane that intersects our profile, which all of them do. And I'm going to create a straight line. Now, the length of the straight line is kind of important, but we need to make sure that it at least comes out of the part. It can come out of the part, or it can exactly match the top. I'm going to do an intersection curve with the, actually, not an intersection curve, sorry. We're going to do a intersect with this top here, and then we're going to snap that to the top. Now, the reason I say this is important is because the way we're going to make this cut is by doing a sweep of this profile along this path. But we want to have it spiral around like a true thread. So the twist angle is going to give us that. I'm going to have it spin one full revolution, 360 degrees, and that's going to give us our complete cut. Now, you'll notice that it maybe does something funky here at the edge. That's okay because we're going to pattern it. And remember, the way that we define the inside of that is to completely get rid of the middle. So we're going to pattern that last feature. We're going to pattern it about just some axis of revolution. You can select a cylindrical edge, or you can select the Z-axis if you want. It's all going to work the same. And remember, we used 5 as the number of instances that we wanted. And that was how we came about this shape. It gave us 36 degrees on that one side. So again, the reason that's important is because it's going to completely cut away the middle. So that's why we did that with that 5 millimeter line at 36 degrees, and then we mirrored it to the other side. Next, we're going to bring the other body back, and we'll just use combine. Pretty straightforward. Make sure that you're set to cut. The target body is the complete cone. The tool body is the one that we just cut. And we want to make sure that we are keeping the tools. This will keep a copy of the original, and then it'll leave us with basically the inverse of that. Now, the last thing that we actually need to do here is we need to offset all of this geometry, well, with the exception of the outside. The outside's fine. We're going to offset that using press pull. Now, the amount that we offset it is going to be dependent a little bit on your 3D printer. If you're using, let's say, an SLA 3D printer and printing this with a resin material, or depending on which type of FDM printer you have, you may find that you need to have a larger value here. Now, I've printed a couple of these. The smallest offset value I've done is minus 0.2 millimeters. And that worked okay on my K1 Max for a print that was smaller than this. If you want it to be a little bit looser, I would suggest going to something like minus 0.4, minus 0.5, somewhere in that range. All the parts will still fit together just fine. It'll just give you a little bit more gap between them. So for this example, I'm going to use minus 0.4. So that, depending on your geometry, could take a little bit of time for your computer to calculate. But what we should see here is that there is a gap between all of our parts. Now, in reality, if that gap is large enough, you could do a print-in-place model. That's going to be solely dependent on your printer and the way in which your tolerances work and your trace widths and the needle and the nozzle size and all that kind of stuff. You can certainly try it. I personally suggest just taking one of these bodies and moving it off to the side and printing them separately. But if you want to try to print them together, go ahead. Some other things to consider that might help this is adding small chamfers to the lead edges. It can be tricky, especially because we've got some sharp corners here. But if you want to make the process a little bit easier, just add a small chamfer. It can be 0.2, 0.4, 0.5, whatever the case might be. You don't have to do it, but having that small chamfer on the edges certainly does help a little bit, and the printers can print those just fine. 0.2 may be a bit small. 0.5, you have to be careful because some of these areas start to get pretty thin, but that might also help if you're trying to do a print in place. So you can see that looks like maybe I grabbed all the edges. It looks okay. So that's pretty much it. That's all you have to do. So now if you want to take this and print it, just save it as a mesh, send it to your slicer, and make sure that it works. So let's go ahead and take a look at it in the slicer as one piece and see if we can actually do a print in place version of this. So with it, I'm just going to go ahead and slice it with my default settings. And what we would want to look for here if we're trying to do a print in place model is to make sure that every layer has a very specific gap between the two different parts. So I'm going to scroll down, and obviously I've got some infill set. Let's just rotate this around. And we can see there is a gap between this layer and this layer as it's building up. But again, this is very much dependent on your printer. So if you happen to try to print in place like this and you have a problem, then it's going to be nearly impossible to break these pieces apart. But there is enough of a gap if you're using something like 0.4 or 0.5 millimeters. So that's it. That's the basic process. And it's really fun to play with, but keep in mind if you are making these for, let's say, your kids, there is definitely a noise that happens when the layer lines rub against each other, just because of the nature of the print. So while it is a nice fidget toy to occupy some idle hands, the noise may be a little bit too much to handle. So just keep that in mind if you are handing these out and you're using an FDM. Now, if you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.